Have a great and wonderful day to everyone. We are the Garner Group and we are BSED Mathematics 3A. This is the part 2 of our bird feeder activity.
Number 1. Define your system and your environment. Our bird feeder contains 4 halls and 6 halls. We have 3 locations for our bird feeder. First is in the tree near the house. Second is in the bamboo at the center of the field. Then third is in the roof at the back of the house. Describe your system and environment and present your observation as well as adjustments that you made. In our bird feeder, we're doing trial and error method. In our first, second, until 6th try, there's no bird coming in the bird feeder.
So, in plotting the data in XY plane, we're going to identify first what is independent variables and the dependent variables. Wherein, in this activity, the actual bird feeder, the independent variable is the time, while the dependent variable is the height. Next, we have bird feeder A in 6 holes for first location. In time elapsed in 0, the feeds is 16 cm. After 1 hour, the feeds is 14 cm left. In 2 hours, 12 cm left. In 3 hours, 9 cm left. And in 4 hours, 7 cm left. And in 5 hours, 5 cm left. In 6 hours, 2 cm left. And after 7 hours, only 1 cm left. Next, we have the table shows about the 2 data sets, the first location and the second location. So first, this table shows about the bird feeder A in 4 holes. So wherein we have the time elapsed in hours and the height of feeds in centimeter. In 0, 16 centimeter. In 1 hour, 15 centimeter left. In 2 hours, 14 centimeter left. And in 3 hours, 12 centimeter left. In 4 hours, 9 centimeter left. And 5 hours, 7 centimeter left. And in 6 hours, 5 centimeter left. And in 7 hours, 3 centimeter left. And after 8 hours, only 1 centimeter left. So next, in second location, bird feeder A in 4 holes. We have in time elapsed in hours and the height of feeds in centimeter. And 0, the feeds is 16. In 1 hour, the feeds is 15 left. And in 3 hours, the feeds 14 left. And 5 hours, 13 centimeter left. In 7 hours, 11 centimeter left. And 9 hours, 9 centimeter left. And in 11 hours, 6 centimeter left. And in 24 hours, the feeds left is 1 centimeter. And next, this table shows about in second location for bird feeder A in 6 holes. So in time 0, the feeds is still 16 centimeter. After 1 hour, the feeds decreases into 15. Then, in 3 hours, decreases in 13. In 5 hours, decreases into 11 centimeter. And 7, decreases into 9 centimeter. And in 9 hours, decreases into 6 centimeter. And in 11 hours, decreases into 3 centimeter. And last, after 24 hours, the feeds equal to 1 centimeter. The XY plane of bird feeder with 4 holes in both first location and second location. This implies about the difference between the two data sets. And in relation to variations, the data could be expressed as inversely proportional because as time increases, the height of the feeds decreases. Likewise, in XY plane of bird feeder with 6 holes, both the first location and second location. As time increases, the height of the feeds decreases. Though the consumed with bird feeder with 6 holes is longer than the bird feeder with 4 holes because they didn't the same location. That's why the birds adjusted the new venue.
And now for our scatter plot. For our first location that has 6 holes, we both use linear and polynomial curve fitting. For our linear, we have y is equal negative 2.2381x plus 16.083. And for our polynomial, we have y is equal 0.0238x squared minus 2.4048x plus 16.25. Next is for our 4 holes in our first location. We also use linear and polynomial curve fitting. For our linear, we have y is equal negative 19833x plus 17.044. While in our polynomial, we have y is equal negative 0.0574x squared minus 1.5245x plus 16.509. For our second location, for our 4 holes, we also use linear and polynomial curve fitting. For our linear, we have y is equal negative 0.6493x plus 15.495, while our polynomial is equal y is equal 0.0128x squared minus 0.9573x plus 16.425. Lastly, for our second location that has 6 holes, we also use linear and polynomial curve fitting. For our linear, we have y is equal negative 0.6602x plus 14.201. While in our polynomial, we have y is equal 0.0344x squared minus 1.4873x plus 16.701. Now, let's talk about the actual and the calculated values. Let's differentiate and compare the two values. For our first location that has 6 holes, this is our actual value and the other one is the calculated values for linear and polynomial values. So, our linear is equal y is equal negative 2.2381x plus 16.083. So if x is equal 5, then the calculated value is 4.8925, while polynomial is equal y is equal 0.0238 x squared minus 2.4048x plus 16.25. If x is equal 5, then the calculated value is 4.821. So, the calculated value and the actual value is just almost the same. They only differ from points. Next is same location but has 4 holes. This is our actual values and the other one is the calculated values. For linear, we have y is equal negative 1.9833x plus 17.044. If x is equal 5, then the calculated values for linear is 7.5235. Then for the polynomial, we have y is equal negative 0.0574 x squared minus 1.5245x plus 16.509. If x is equal 5, then the calculated values for polynomial is 7.4515. So, as we can see, the difference between the actual and the calculated values for linear and polynomial is just a point or points. Next, for our second location that has 6 holes, this is our actual value and the other one is the calculated one for linear and polynomial. For our linear, we have y is equal negative 0.6602x plus 14.201. If x is equal 5, then the calculated value for linear is 10.9. While in polynomial, we have y is equal 0.0344x squared minus 1.4875x plus 16.701. If x is equal 5, then the calculated value for polynomial is 10.1245. So, they only differ from points. Lastly, for our second location that has 4 holes, this is our actual value and the other one is the calculated value for linear and polynomial. For our linear, we have y is equal negative 0.6493x plus 15.495. If x is equal 5, then the calculated value for linear is 12.2485. Then for our polynomial, we have y is equal 0.0128x squared minus 0.9573x plus 16.425. If x is equal 5, then the calculated value for our polynomial is 11.9585. So as we can see, same from our previous actual and calculated value, they only differ from points.
So, here's our conclusion. Upon conducting the actual bird feeder, we realized the significance of modeling, especially in applying it in real-life situation. Likewise, in observing the actual bird feeder, we identify the consumption of the height of feeds as time passes by. In this activity, we use curve fitting both linear and polynomial so that we could identify what's the best model really fit to the data we gathered. And based from our scattered plot, we decided the best model in this activity, the actual bird feeder. Thus, we therefore conclude after we computed the actual value and the calculated value using the both polynomial and linear curve fitting, we could say that our model that we get in our actual bird feeder is correct. Why? Because though they are different in decimals, but they are closer to each other.